Hey, all. Welcome to the Uptime Wind Energy Podcast. We have 3 items on the docket. Rosemary talked a lot, and so we had to just condense everything, but it's very good. In fact, she was in a very combative mood today, I have to say. So she was ready to go, all fired up. First topic is Aerones, Latvia, getting $9 million in funding, and we try to connect that funding to what the future marketplace is. And we think there's huge upsides for them.
And then I get on my high horse a little bit about waste to fuel and to what extent that can be called green, or maybe it's more towards greenwashing.
So GE renamed themselves GE Vernova on the energy side, so renewables and the rest of their energy portfolio. And we're going to put on our marketing hats and talk about that for a little while.
Stay tuned. It's a good episode, everybody. We'll be back right after the music. Well, funding news this week, guys. Aerones up in Latvia received $9 million in investment funding. And I bring this up because usually these investment pieces don't make a lot of news, but one of the companies that invested in Aerones decided to write up a really detailed long article as why they invested in a company in Latvia. And it was a little bit a different perspective on the wind energy community in terms of potential growth, why they think there's going to be significant changes over the next couple of years, and why other companies are not getting invested into in terms of wind companies. You don't see a lot of investment in wind companies. The earlier one this year was SkySpecs, which is $80 million. Aerones is $9 million. But after that, it gets pretty quiet. So the funding company was Future Positive Capital. They led the round with a couple of companies you probably recognize, Rosemary. Change Ventures, Skype founder Jan Tallinn, Vinted co-founder Montes Mikukas, Printify CEO James Bertigans, and then Pace Ventures and Eco Summit and Capitalia. So there's names that I recognize in that list. So they all invested in Aerones as a potential growth company. And the reason they did was interesting. It said in late 2000s, the North America wind fleet was already average 7 years old, and that was expected to be 11 years old by 2025. So they're seeing this aging wind turbine market. And Europe has pretty much the same difficulty, where more than a quarter of the wind turbine is going to be more than 15 years old as of 2020. So they have older wind turbines out in service, and they need to keep them running. And maintenance costs increased roughly 15% in years 10 through 15. And Joel, I think you've seen this too on wind turbines. When they get past year 10, they're just really in trouble. It takes a lot of energy to keep the turbines running. So the investment was based upon those numbers of, hey, we see a lot of wind turbines getting older. Hey, we know that a lot of maintenance has to be done on years 10 to 15, and all those wind turbines are hitting into that repair suite market. And they think that the global maintenance market is expected to double over the next 10 years from roughly $30 billion today to a $60 billion market. If that's the case, it seems like that's a pretty strong growth market. It's probably not Silicon Valley money or SaaS startup of some sort, but it's getting into that realm of really fast-growing companies. And with the economic downturn, I kind of wonder if wind and wind repair companies are going to be some of the faster-growing companies in the States, or if not the world. And Joel, you're probably a lot closer. I know you are. You're a lot closer to this than I am. Is that what you're seeing too, that there'll just be a lot more emphasis on repair and maintaining what's already out in the field?
Yeah, I think up until about 2013, 14, 15 in the U.S., they treated blades as they weren't a repair item, right? They weren't even on the list. It was, and then all of a sudden you had all these, oh man, we really got to work on these blades. So now you've had 8 years of an industry catching up to that. But I think one of the things that makes it easy to understand from an investment standpoint for the people investing in Aerones, first off, I think they got a steal. I think that Aerones is going to do great. But it's an easy market to validate because I know today I can tell you there's 71,000 turbines in the United States. It's pretty easy to understand your target markets, the value, how much cost is going into them. It doesn't get a whole lot better than that. There's a finite market. But the problem being in the U.S. is SkySpecs has showed you the same thing with the explosive growth of their drone platforms and the money they got. It's hard to get technicians to go work on these things. Not the expertise isn't there. The bodies aren't there. The ability to bring people into that market. I mean, because think about these are guys who are mostly all working on blades. Now, Aerones does some LPS system checks. They do some cleaning. But it's mostly what would be done by either platform access or rope access technicians. And if you can maybe run 2 of these robots from the ground with 2 people, you don't have to have people that are highly trained to be on ropes, because that's one thing. And then you have to combine that with the ability, if these things are doing repairs or leading edge work or whatnot, then you have to combine that with the ability to have composite skills. So your possible workforce keeps getting smaller and smaller and smaller and smaller and smaller. So if these guys can, there's some up and coming robotics companies out there as well as Blade Bug is out there, Rope Robotics is out there. There's people getting into the space. If they can nail the quality, the commercial portion of it is basically already established. So if it's quality and speed they can get, they will do very well. I think $9 million. If Aerones is, they'll do $9 million of the revenue work next year.
Yeah, I would say so. Yeah, that makes sense to me too. One other aspect is the offshore growth, that the investors believe that offshore is going to be big. And again, when you talk about finding technicians to do offshore work, you're talking about even a smaller subset than onshore, just because of the skill sets required, right? And so that's going to lead to more robotic work. And I think this makes a lot of sense in terms of an investment. I just don't see that going to Rope Robotics, for example, or Blade Bug. You just don't see those kind of investments. And maybe they are happening.
Yeah, why not?
Right. Why not? Yeah. If the market is that hot and the potential is that hot, you think you'd see a little more activity in terms of that marketplace. And at the same time, I had a discussion with someone talking about blade erosion, which is one of the main killers of blades, that leading edge erosion is very predictable. That was the argument. Leading edge erosion is very predictable. And I was thinking about that over the weekend and saying, I don't think that's the case, actually. I think every blade that comes out of the factory is slightly different. And leading edge erosion is one of those things that finds those weak spots, and not every blade has the same weak spot. So you get this sort of unevenness that happens out in the fields, particularly as the blades get older, which just leads to sort of a little more panic, I think. Like, oh, this blade's really having trouble, and that turbine over there is, you can wait a year or two. So it just leads to sort of more chaos in the marketplace, where a quick fix may be the right solution.
Well, I can say right now, I know of 2, and I know intimately of one university project or group projects, joint industry ones, that are trying to address exactly that, blade defect forecasting.
Yeah.
Right. So they're trying to understand, if we know all of the ambient weather conditions, and we know, we're getting sea spray, we're getting this, say you're an offshore wind farm, or you're in West Texas, and we know how much particulates in the air, and we can map out a subset of this farm on year 1, 2, and 3. Okay, then by year 5, 6, 7, 8, 9, 10, we should be able to forecast what they're going to look like. Now, then you mix in the science and art part of composites and blades. So I totally agree with your point there. But from a general standpoint, I think you can if you could get even from 0% accuracy where we are now, kind of going like, oh man, these look bad. Good thing we got an inspection. If we can get to the point where we're even accurate to plus minus 20-30% of what that leading edge erosion looks like by forecasting it, then we're in a better spot, right?
Yeah, I think in an ideal world that would be possible. But Rosemary keeps telling me that the blades are a handcrafted product, that there are no 2 blades that are built the same. And I think, Rosemary, you were the one who was telling me about air pockets in the leading edge, and that helping to contribute to some of the leading edge erosion issues. Plus, there's a grinder and a person on every blade trying to smooth them out. So they're not the same. So is it?
No,
does it become the
they're
case?
not the same. But I think you're both right. I mean, they're predictable. It's predictable to a certain extent. And I think with leading edge erosion, it's got really a lot to do with the external conditions, like the droplet size and the amount of dust that's in the droplets and stuff like that does have a really big effect. And then, of course, like it's not like you would be able to look at a blade and say you're going to get leading edge erosion in this square millimeter here and not over here. That would be a blade by blade sort of thing. But I think that what you need to be able to prioritize maintenance in one wind farm over another, and maybe even one like row of wind turbines over another row of wind turbines in a wind farm, I think all that's going to be quite predictable. And I just want to go back to you raised about one of the reasons why there's been this investment in Aerones is because of offshore emerging, and you wondered why we don't see the same investment in all kinds of
right.
I don't know, advanced maintenance. And I think that it's not just that offshore wind is going to get huge and so every single maintenance company is going to do well. I think offshore wind can only get huge if the maintenance technology improves a lot, because, maintenance is already a big chunk of the costs for an onshore wind farm. And, in a lot of ways, that's great because it creates heaps of high-skilled jobs. But, when you take that same amount of maintenance and you scale it up for the increased size of the turbines offshore, and then, up a whole bunch more, much more significant is the fact that it's offshore in this really hostile environment. It takes a long time to get to it, and all that salt water. I mean, even building a wind farm that's remotely near any salt water means you get way, way accelerated aging on pretty much everything, even things you would have. No, it would, your intuition says that salt water shouldn't make any difference, but, it does. I think that we need the right maintenance companies to develop the right technologies to actually enable offshore wind to grow. Otherwise, I see this, huge ticking time bomb of maintenance costs being much, much higher than anyone expected in a few years when the first surge in offshore wind farms get old enough to start having problems. I think it could be really bad. So I think it's really important that, investors are looking at which companies have the right technology, but probably more importantly, the right team to, respond to what are the challenges that we're really seeing and develop technologies to help solve them, in a cost-effective way. Otherwise, I think that it's going to hinder the offshore industry. So I think it's like, it's two parts of the puzzle. They need to go together. You can't have, just this huge surge of offshore wind without having a huge surge in wind turbine maintenance technology. You need both together for either of them to work.
Well, Rosemary, do you think that Aerones will have to have a robot on every offshore turbine? Do you think that's the projection as we go forward, is that every wind turbine will have, because of the size and the location, you're not really close to shore, most of these turbine installations, will you have to have robot or robots on every turbine platform?
Yeah, maybe it will work out that way. I don't know. I think that would definitely be a possibility. And if they can get the cost of their robot down enough and, the cost of getting between turbines and the wind farm stays high, then you might see it move towards that. But maybe can you explain how does the Aerones system work? Because it's not
offshore?
It's not just drones, right? You don't just fly a robot out to a blade and it clings on and does its thing. Can you? Yeah,
I have seen that.
To explain how it works.
Okay, so
that's a thing as well, but it's not Aerones thing, right?
No, it's not. There's a company in the States that's looking at something very similar to that. What Aerones has talked about in some recent webinars that I've been sitting in on is basically a gantry. Is that the right word, Joel? It grabs hold of the turbine tower and it's got this like gantry thing to it that reaches out to the blade.
It looks like if anybody in the wind industry, if you're familiar with field operations, it looks like what a 360-degree platform looks like onshore, where the legs kind of go against the tower, and then the platform can go up with it. Because the Aerones onshore, when you see the robots, they have all these guy wires and stuff coming out. Like, well, we don't have the ability to do that. You have to either work off the transition piece, work off of an Ampleman platform from an SOV or something of the sort, or have something like that 360-degree platform-ish looking thing that basically puts wheels on the tower, slings up to the nacelle, and then pulls up. I think that the slam dunk, Rosemary, and exactly what you're saying is the cost. Like if you're on an SOV, if you need an SOV to deploy this robot versus a CTV or something else, you're $25,000, $30,000, $40,000, $50,000, $75,000 a day just for the vessel.
Wow.
Now I know of one. I can't remember if they're an OEM, but it was someone that holds an FSA. So either the OEM or whoever the full service contractor is. They recently did this big cost study. It was in German waters, that they decided that it was more cost effective to mobilize technicians to work on turbines offshore with a helicopter than it was with an SOV.
Wow. So
they've started taking them to the top of the nacelle with a helicopter versus using an SOV for everything because it's just cheaper.
Gosh. So they're physically dropping them off a rappelling line onto the nacelle?
Mm-hmm.
Wow, that's crazy. I have not heard that. It makes sense to me because it would be less money and probably, as long as the weather's not bad,
for that
you could
job.
probably do it.
I think that sounds really fun.
No, you wouldn't.
I mean,
I've never been in a helicopter before.
It's not a lot to write home about. I'll put it to you that way.
I've never hung underneath one. I can tell you that.
Don't you think that would be super fun job
to
fly around in helicopters and rappel off them to grab onto wind turbine blades? I mean, that's a good job.
No,
they'll have people lining up for that, and I bet it pays really well too.
I don't think you understand what the word "good" means right now, because that is the opposite of good. Helicopters are not meant to fly.
When I climb,
when you go winter,
turbines,
summer, it's opposite.
It's opposite, right? It's south of the southern hemisphere, right? It just everything's backwards. It must be something in the translation with electrons go north, right? Because that does not sound fun to anybody, unless you're like an Army Ranger and you're dropping out of helicopters, a Marine or somebody.
That's just because you guys are those lame office engineers that everyone likes to complain about.
Okay.
Get on site and get your hands dirty.
Okay. I got my hands plenty dirty. But I know where my limits are. I don't like falling into the ocean from 200 meters up. That does not sound like fun.
No, I do get what you mean because I went to a lot of effort to be trained and be able to climb wind turbines. And the first day of any trip that I do, I'm like, this is the best thing ever. My job's the best. I've got to get out and climb wind turbines more. But like by the 5th day of the visit, you're like, oh, my harness is so heavy. It's so hard to move around. And, like you're up there all day and you can't go to the toilet. And it's, it's just, it does become a bit of a grind. So maybe the first couple of helicopter trips, the training for the helicopter repair job would certainly be fun, and then the first little while would be really cool, and then it would probably be very tiring job.
I've watched two people completely lose it during helicopter, like Bosie at Hewitt training. Flip the helicopter fuselage over in the pool, sink it in. You got to find your way out. I've watched people lose their minds in that and have to get rescued.
I had someone lose their mind in a confined space training that I did where we were crawling through these smoky tunnels with oxygen tanks strapped to our back. And this one guy freaked out and actually managed to crawl over me in this tunnel that's barely bigger than a human on all fours. He actually managed to crawl over me and get out. And when I talked to him later, he didn't remember that he had done that. He was just so panicked that so he was exempt from the rest of the training. But, I love all that stuff. That's
a fail.
I love it when I get to do the training.
That doesn't sound very. It doesn't sound like something I want to sign up for. But this is why the investors in Aerones think that this is going to be a huge marketplace. And give me a rough number. Give me a rough number what you think a wind turbine operator would pay for a robot per turbine. $5,000, $10,000, $50,000.
it depends on what everything you're getting done, right? If you're somewhere where like I think about the German market because
Right.
they have I'm saying statutorily, either way. They're the only place I know that has you have to test your lightning protection system every year,
France
right? By
does
law.
too. I think France does every other year.
Okay,
yeah.
so France is, and France is a little bit more lenient, but Germans have to do it. So I could see robots for certain things per wind farm, like onshore, because you mobilize them with a pickup truck. It's pretty simple.
Right.
But if you put together the O&M cost, I mean, it's a pretty easy ROI study. If Aerones says we can redo your leading edge for $10,000 per turbine, and we'll also test your lightning protection system with the same robot and just change out some. I don't know if that's exactly how their system works.
Yeah,
but if
it's
you
a
could
little
change
switch
out a
out
head
thing.
and you can
Yeah.
So it's a transformer. And
Right.
just change some tools out. I could see an 80 turbine wind farm owning one of these, and taking on some
onshore,
training
yeah.
and being able to
Sure.
and being able to take on some of these O&M activities with their own people rather than having to bring in subcontractors and pay travel and demob, all this other stuff that adds up. So if you can take, if you have a big blade campaign, you could be anywhere from $300,000 to $1 million over a season. You could probably buy one of these robots for cheaper than that, and then have them do it every year with some maintenance.
That would make sense. Offshore.
I mean, if that's a business, if that's a business model, it's possible.
And offshore, if you got 12, 15 megawatt turbines, say you got 100 of them off the coast of New York.
Mm-hmm.
You think that business case makes sense? So you think it's $100,000 per robot and all in?
I see it resident. I see it as resident. If you have an SOV, like we'll take the Princess Amelia Wind Farm of the Netherlands. There's a section of those that are there's 5 of them right in a row right there, right? And so they have SOVs that are on permanent hire. They have a contract through 2034. Well, they should be buying one of these robots and putting people on the SOV that can run it, or training people in the SOV that can run it, and having it out there at all times. Because then if they have some slack time, some downtime, you want to do a little work at night,
Sure.
you have the ability to have the asset there. Right, instead of mobilizing people and demobilizing people in kit and all this stuff, just put a 20-foot Connex box on the deck of that SOV that has all the Aerones stuff in it, and then whenever you've got any time, you can go and check an LPS system. You can go and clean, do some tower cleaning. You can go and repair a leading edge, whatever you need to do, whatever capabilities they have. But that's what I would do. But I don't run the world.
So knowing all those numbers now, what valuation would you put on Aerones as 5 years from now? Will it be $100 million company?
Yep.
You think so? I think so too. Weirdly enough, I do.
I think it's quicker than that.
It may be, yeah.
3 years.
3 years.
If they can build enough, so they have some capital now. If they can build enough robots fast enough, and if they can train the people up fast enough to run them, because they've proven their technology. They're all over the world trialing it with people and making things happen.
Sure.
As long as the quality is there in the deliverables of the product, as long as the robot works well and it's safe, they've gone through all those things. How fast can you build them, and how fast can you train people to run them?
And of course, in any sort of financial discussion, do not listen to engineers on podcasts to make investment decisions. Do your own research.
Exactly.
Engineers are the worst.
The little SEC, the little star SEC thing. Like, this is not investment advice.
Red light behind me. Alert. Yeah. So we're going to keep following this, and Dinas and the crew in Lafayette have done a really good job to get to this point.
I want to not miss something as well that Rosemary said 5 or 10 minutes ago. When you invest, you're investing in a team.
Right.
Right? You have a product, you have technology, you have the commercials, you have all these metric things. But the intrinsic that you cannot actually measure is that team. And I know, Alan, you've met Dennis many times. Yep. I have as well. Everybody that I've ever talked to or dealt with over there, they seem like a great team.
They're hustlers. So, they're working hard. Yeah, they really are. And the webinars, if everybody gets a chance to watch the webinars, they're free. They're about a half an hour. They're well worth your time just to see what the state of the art is, and it's good to see. And these guys that invested $9 million into this company, I'm sure the valuation is probably somewhere in the $20-30 million range at the moment. So they're going to triple their money maybe in 3 years. That's not a bad way. It's not a bad investment.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the UPTIME Tech newsletter at weatherguardwind.com/news.
We're talking about WasteFuel, which is a sort of a Silicon Valley startup company that's going to take landfill gases from landfills and also take CO2 from the atmosphere and make electrolyzed hydrogen to create what I guess I'll call e-methanol or green methanol to
Biomethanol.
fuel biomethanol maybe to power ships. That the shipping industry needs to find a renewable fuel because there's a lot of constraints can be placed on them in 2023, and they'll have to slow down the speed of the ships unless they can find some kind of fuel which is quote unquote green. Now, Rosemary's argument is it's all greenwashing, and that may be true. I do not know. But it sounds like WasteFuel has investors. In fact, Ørsted, I think, invested in them. Well, Maersk. Sorry, it wasn't Ørsted. It was Maersk. Maersk, Mark Benioff's Ventures, NetJets, which is the big charter jet company, at least in the States, and one of the Gettys as in Getty Oil, invested in this. So it's not completely off the charts in terms of the technology. These people would tend to do their homework. So, Rosemary, why is it not green? Why is it greenwashing?
Well, it depends what waste that you're turning into fuel. So I've just been having a quick look at their website, and they give really no information about what their processes are, which to me is a red flag, and probably means that it's not, maybe amongst the best. But they're taking municipal trash and agricultural waste and turning that into low carbon fuels, renewable natural gas, and green methanol. So, I mean, there's a bunch of ways that you could do that, and I haven't seen how they're specifically doing it, and some of them are more green than others. So if you're taking municipal waste, that's not just like one homogeneous product. It's full of all sorts of different things. If you just burn that, for example, you can get electricity as a result from that. Oh, sure. But it's not green because most of what you're burning is fossil fuel origin. If you're burning plastic, then that is that's made from oil in the first place. So you burn that, you release the CO2. I guess it's possible that they're taking a regular landfill, capturing the methane that is the result of anaerobic digestion. I'm not sure what the process is called.
Decomposition,
the normal thing that happens when you have a landfill is stuff decomposes and releases methane. So if they're capturing that, then and doing something with that methane, then that's good. But I mean, landfill gas capture is not like a Silicon Valley startup new technology. That's something that's been around for ages and is definitely an improvement on just landfilling in the existing way. But anything that they're doing to take if there's plastics or anything in there, it's of fossil origin. And so you take some fossil origin plastic and then turn it into a fuel. You've gone from oil to fuel via a few extra steps. It's still a fossil fuel, at the end of the day. So, I mean, I guess you're relying on the fact that green is this really, really vague term, and people don't like landfill. True. And so they'll assume if you have less landfill, that's a green technology. But I mean, to me, when you're talking about green fuels, what you're talking about is less climate impact. That's the meaningful part of that to me. And it's not going to be less climate impact. It's going to be worse for the climate because you're taking something that would have stayed underground in the landfill. While you got plastic in landfill, it's not decomposing and putting CO2 into the atmosphere. The plastic just stays there. I mean, that's one thing people hate about it. So if you burn that or release its carbon into the atmosphere in any way, then that is going to be, like there's going to be a climate impact from that. It's going to have greenhouse gas emissions. Sure. And so from that point of view, it's not green. I mean, maybe it's green compared to if you assume that you're only displacing fossil fuels, when you got this new one. But if you compare it to actual renewable resources, it's worse for the climate. So that's why I say it's greenwashing.
So if they took the hydrogen that we were creating from wind turbines that are offshore on the coast of California, when that happens, and then pulling CO2 from smokestacks somehow and combining those two to make methanol, or biofuel, is that not greenwashing? I'm trying to understand where the line is here.
Well, I mean that if the hydrogen comes from a renewable resource and whatever power that you use to extract the CO2 from wherever you're extracting it, if that was renewable as well, then
right.
I think, that I don't think that that's greenwashing. I think that that's a, expensive way of resource intensive way to get an end result, but I don't think it's greenwashing. No.
What's less? No, that's a good input. Yeah. What's less intensive? What's less energy intensive than making methanol? Because it seems like there's this really concerted effort to do hydrogen, but then there's a lot of negatives about hydrogen, of which you've informed me about. Like the hydrogen getting into the upper atmosphere is very bad for the climate. We don't want to do that. So if we're not going to do hydrogen, and because of difficulty using it, it's going to be really cold, all these different problems with it. Seems like methanol is something we made for hundreds of years, and we know how that process works. And maybe it's expensive to create, but if we're going to put these artificial barriers, I'll call them in terms of shipping fuels and aviation fuels and other petroleum-based modes of transportation, what else are you going to do? It seems like you're all of a sudden you're funneled down into some sort of renewable methanol.
Yeah,
Isn't
I mean, if you need methanol,
really the answer?
then if you need methanol, then there's certain green ways to make it, and that's fine. But the issue where I would say it's more resource intensive than it needs to be is if you're using methanol for something that you could just directly electrify. It's the same issues with hydrogen. It takes a lot of energy to make it and then release the energy again. So it's only when you're comparing things that could be electrified that people, it's like that saying, when all you've got is when the only tool you've got is a hammer, then everything starts to look like a nail. And I think that hydrogen and even green methanol and ammonia are a bit like that. People are really scrambling. They're like, oh, I see the potential of this. Now they're scrambling to find things to do with it instead of looking the other way around. Oh, we've got a problem that we need to solve. What's the best way? And that will be electrification if it's possible to electrify something. Then that will be the more efficient and ultimately cheaper way to do it. But you can't electrify everything. And a lot of the things that they're planning to do with methanol are things that are not easily electrified. And so in that case, yes, go down that path, make it green methanol, and that's great.
Airplanes.
As long as you don't start looking for extra things to do with your methanol or your green hydrogen now that you should have done. Because, like if you take example of a fuel cell electric vehicle that runs on hydrogen, and you compare that to an electric car, the number of extra steps that you need to get the fuel cell car working. You need to first of all generate the green electricity to drive the electrolyzer, which needs to make the hydrogen, and then you need to get it to where you want to use it. So you're going to have to compress it, maybe liquefy it, transport. And at the end of all of that stuff, and then, back into your fuel cell to convert it back into electricity to drive the car, you end up needing 3 times as much green electricity as if you just, connected that wind turbine into the grid and then into the, power socket that charged your electric car. So, that's what I mean about, if you can directly electrify it, then no one wants to see 3 times as many wind turbines as the minimum number necessary, even me, and I love wind turbines, but I want the number that we need, not 3 times that number, because we chose to go via hydrogen. So that's the point that I'm trying to make.
So quick question for you on that, Rosemary. If you have, say, 10 liters of space, 10 liters of compressed hydrogen or 10 liters of battery pack, what's the smarter way to do it then? Because I believe that the 10 liters of hydrogen power will get you a lot further than the 10 liters of space of battery power. And why it comes to my head is I know a company up in Canada, actually off the West Coast, that developed a hydrogen fuel cell for a subsurface AUV. And when they had it on batteries, they could get like 1,000 kilometers of range out of it. They put the the hydrogen battery in there, and now they can get almost 4,000 kilometers of range out of it.
Yeah, so I don't know that exact comparison. I tried to quickly search it, but couldn't find it. So hydrogen has a really great gravimetric energy density. So per kilogram of mass, there's heaps of energy in hydrogen, definitely compared to batteries, but even compared to other traditional fuels, it goes really well by weight. But it has a really bad volumetric energy density. It's a very, very low density gas, and it's the smallest molecule, right? So in its natural state, it takes up a lot of space to get the same amount of energy. And I don't know what comes out in front in volumetric energy density between batteries and hydrogen, but I don't think it's hydrogen. Hydrogen just takes up a lot of space. And if you want it to take up less space, then you have to cool it. I think it's boiling point's like minus 253 degrees or something like that, like pretty close to absolute zero actually. And so the amount of energy that you have to keep, keeping something at that temperature, if it raises above that, then it boils off. And I mean, even at that temperature, you're still going to get some boil off. So you're not going to be transporting it around in liquid form a lot. It is like, that's why when you see these, concept airplanes, hydrogen powered airplanes, they've all got these gnarly shapes because they've got to fit all that hydrogen somewhere volumetrically, even though it doesn't add a lot of mass compared to a traditionally fueled airplane. It certainly adds space. So yeah, there's not some applications you don't care about space at all. Like, if you've just got a big cavern and you want to store energy, you probably don't care how much space the hydrogen takes up. But sometimes you do.
Yeah, and I'd have to look, but I think that this concept was using, or not concept, this practice was using liquid hydrogen, but it makes sense because this thing goes down to 3,000 meters of ocean depth. The temperature is 1 degree C, so it's a lot easier to cool it. I mean, of course, it has to get a lot colder, but it's a lot easier to cool it there than it is at 80 degrees out in the sunshine.
Yeah, but it's only, 20 degrees Kelvin difference out of 250. Yeah. Like, it's not probably that big a deal, actually. Yeah. I mean, it's easy. It's tricky when you're dealing with temperatures. And I mean, I guess you've got different challenges in the US with using Fahrenheit, but it's one problem that I see people making over and over again is, you've got something at 5 degrees Celsius and then you've got something at 10 degrees Celsius. Oh, it's twice as hot. And you're like, well, no, it's not. You can't, if you want to talk about temperature in that way in terms of it, percentage differences or, like what's a safety margin for a temperature, 10%. So, if it's operating, this is design temperature is 20 degrees or 10% is from 18 to 22. I mean, that doesn't make any sense. And you can see that if you converted that to Fahrenheit, then you would not have your 10% anymore. So, yeah, I'm not sure that it's actually going to be that different. Like, I think 20 degrees difference might be a rounding error when you look at the energy that is required. I mean, you get all the pressure. Yeah, the pressure would probably help because, obviously pressure, temperature, really high pressure. Density are all related. Yeah. PV
equals nRT.
Yeah, that's rules. One formula I remember from high school.
One. Is that the one you wrote down? Yeah.
It's like one like that for every field, It's the same with my electrical engineering. It's like, V equals IR and P equals IV.
There you go.
You can get a long way with those key formula sticking that one equation that sticks in your mind from every course that you did at high school. Yeah.
So the thing about all this, Rosemary and Joel, is that I sometimes when I'm watching the new technology, particularly hydrogen, I think you realize all that went into the existing architecture and systems that you have right now, and we're just going to put that all in the dumpster. that's not the way industry grows. And I try to relate it to automobile racing. If you watch automobile racing like in the 60s and 70s, if you go back on YouTube and watch these races, there's limitations, right? It's maybe the cars could have gone faster if the tires were better, but the tires weren't better. Or the cars could have gone faster if the aerodynamics were better, but the aerodynamics weren't better. That's just where they were at that time. And if they had the knowledge and all the tire manufacturers all spooled up to do much better tire grip, and aerodynamics is spooled up, and the oils are all different today than they were back then. There's just so many different facets that you have to squeeze out that last 5-10% of efficiency from, and we're just not there. So at some point, you just brute force it. I think it's kind of where we're at right now. We're saying maybe you need 3 times the amount of energy to create the e-methanol. Okay, but that's where you are today. It doesn't mean you're going to be there 5 years from now. Isn't that a sort of a sane approach?
Thermodynamic limits, though. Like you can't double the efficiency of some of these processes. There's like minimal. No. I mean, I'm not a chemist, but there are minimum amounts of energy that you need to take, to do a chemical reaction. Regardless of you get rid of every inefficiency, you still don't get anything for free. That's just the laws of thermodynamics. And,
but the laws of economics don't play out that way, right? I mean, there's engineering laws. Totally agree. But the economic laws, which is where everything makes a difference, do change. And I'll give you the example. We never thought about making 15 megawatt turbines 10 years ago. That was not a thing. And now we could make 25 megawatt turbines. So if we did start putting in California, instead of 10 megawatt turbines, you put 25 megawatt turbines out there, then and the economics scale that way and then costs get reduced, then maybe it makes sense to electrolyze hydrogen. And also to
but the difference
desalinate water, so California had some water.
The difference is that if you've got something else to do with that electricity, it's also got that same improvement in economics. So the relative difference between the hydrogen versus electrification hasn't changed that much. It will change a bit because, electrolyzers, we haven't made as many electrolyzers as we have made, wind turbines and whatever. So there's bigger gains to be made there. Yeah, methanol plants. I mean, these aren't brand new technologies. We know how to make methanol plants. No, they're not new technologies. So they're not like right at the start of their cost reduction curve, but they're not. Still have, the cost reductions go with the doubling of volumes produced. And so if we suddenly start making a lot more, you'll still see the costs reduce. But
we've also put artificial barriers in there too, right? The artificial barrier is you have to either reduce the CO2 emissions coming off of your Maersk ship, or you have to slow down, which is going to cost Maersk hundreds of millions of dollars. So just round it out. So at that point, with these artificial barriers put in place, then it may make sense to own a couple wind turbines. Am I too far off in left field here? It just seems like this is where it's going to go.
When you're talking about industries that aren't easily when you're talking about applications that aren't easily electrified, then yes, you're right, definitely. So I think that we're not really arguing against each other. We're arguing different ends of the spectrum. So, if you look at things that are easy to do with electricity, then it gets gradually harder and harder and harder until it's like impossible to do it with electricity. I think no one would argue that the easiest electrification applications should be electric and that the impossible ones shouldn't be. But there's, some point in between, and anybody who's got a methanol company or, a WasteFuel company or a hydrogen company wants to push that point further towards, find more and more and more things that they could do with hydrogen. And it sounds really appealing to people who aren't really involved in the details, because it sounds very simple, hydrogen economy or, methanol economy, whatever, one technology to solve everything. But the further that you go away from, the niche applications that are well suited to it towards things that you could do in a more efficient way, the more energy we waste and the more wind turbines and solar farms that we have to put in, and the more costs we have to wear as well. So you have to get that right balance.
Mm-hmm.
Yeah, I think that you have to see the support from the outside market as well. So it's one thing to make the fuel. That's what we're basically talking about here, right? But it's also another one to say okay, so back in May, Cummins, America, debuted a 15-liter internal combustion engine that runs on hydrogen.
That's right. Yeah, I remember that.
They won't hit full production until like 2027 or something. It actually went well, I guess.
Yeah.
200 or 300 horsepower, 800 foot-pounds of torque, and it runs well.
But sales.
But they're not going to hit.
Go?
Well, and that's. I don't think they're going to start a regular sales cycle until they said full production 2027. So they still got some kinks to work out in it. But you have to have adoption, by the markets and everything. But it's when you have players like that starting to develop directly usable components, right? Like the electric cars when they first came out. Like I know the first ones in the U.S. They looked kind of weird, and it was harder for people to try to take on something different that was that different.
Yeah.
And then the next generations of them started looking more like a regular car. You just didn't have openings in the front for a radiator. So they look a little bit the same. And that's why I think like the Ford F-150 electric vehicle was soaked up so fast, you can't get one. Like you can't get one. And if it looked odd, like I think the Cybertruck thing like looks odd. It's an electric vehicle, electric truck. It's going to be a different. It's harder to get, right? So, or harder to get acceptance into the general market. So if you have this, like if Cummins starts building a hydrogen motor that doesn't make it that much different of a, like if it goes into like light duty, medium duty trucks or something, where it's not just that shock value, it might be easier to start rolling into some of these things.
As long as you have hydrogen available in the middle of nowhere when they're using it. That's the thing. Like in Alaska, What are you going to do? Or in Australia, in the middle of Australia, there's...
Yeah, we're going on a 2,700-mile road trip tomorrow. If I was trying to drive my truck and pull a trailer with an electric vehicle, I have to stop. I read an article the other day. Every 100 miles with a Rivian, they had to stop on a cross-country trip.
Yeah.
And I'm all for electric vehicles, but that's not practical right now in the U.S. I can't drive cross-country with my truck and a trailer.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
So Rosemary has some very big news this week, and I'm not sure if she wants to announce it to the world, but she reached 2 million viewers on YouTube this week, which is an astounding feat.
Yay!
It's like Mr. Beast and Rosemary. Those are the two. That's kind of how the ranking goes right now. Who's that guy that does all the boxing, Joel? That's on that annoying guy. It's on podcast. That guy too. Oh yeah, one of the Paul brothers.
Oh
yeah.
No.
Somewhere
Get that guy out of here.
Rosemary's up in that level, that stratosphere, which is very good. That's exciting.
Rosemary and Joe Rogan.
And Joe Rogan, right.
Thanks, Alan. I wasn't sure where you were going with that. I'm like, what secret are you about to out to the podcast listening universe? But yeah, no, I was looking at my YouTube analytics, and that little notification popped up. It was very exciting.
Ooh. That's super. Fantastic.
Yeah, it sounds like a lot.
That's cool.
So the big announcement came out today, and everybody's listening to this about a week later, but the big announcement today was GE is splitting into 3 parts, obviously, and each of those new divisions has to give themselves a name. GE Aerospace decided to call themselves GE Aerospace. Okay. GE Healthcare decided to name themselves GE Healthcare. Again, pretty logical. GE Renewable and GE Power, I guess maybe there's 2 pieces there, are naming themselves GE Vernova. I guess it's an amalgamation or a conjunction of the Spanish word for green and the Latin word for new. So it's like green new green. So it'll be called GE Vernova. And we've commented so many times about how GE has great names for the wind turbines. Haliade, X, right? The Sierra. Joel, what's the other one? Cypress, right? Cypress, sure. Yeah. Those are great names for wind turbines, but I'm not sure Vernova fits in that top 5 for me. Rosemary?
I got to think of what it's like to be an employee at GE where if you had some nice polo shirts, because it seems like every 6 months or so they're rebranding, they're joining two divisions, they're splitting another division off, they're putting another. So to keep track of it would be tough. What does your email signature look like today? I don't know. I got a new one on Monday and a new one on Thursday. That's what I feel like it would be like.
It is like that when I used to work for GE. Same feeling. We were sold to Martin Marietta, which then became Lockheed Martin. So we're constantly throwing out notepads and rulers and all the branded stuff, and to get new ones in. It's like, this is such a waste. Why can't I use this old GE notepads? Well, it's no longer GE. We feel like it was not staying in brand. So yeah, I guess all your classic GE Power, GE Renewable stuff is now is a instantly eBay item. I mean, would you run down to the pawn shop and sell it because it's a legacy item?
Did you have those?
I think no matter how they.
Did you have those online trainings
ahead,
when
Rosemary.
you were there? Because that's what it would mean for me. Is like, oh, now I'm going to have a dozen new online trainings in my queue, and I was always late with them. And every time we'd have a team meeting, you'd be like, oh, Rosemary, you are 37 trainings out of date. And you'd be like, oh, this is so boring.
Oh.
Yeah. But I don't know about this new name.
I think
so did you read that somewhere? Oh, yeah, no, they are saying that it is, from
they put
from
it on
green,
YouTube.
Green and new. Because I was going to say maybe they couldn't call it GE Renewables because it incorporates all their, fossil fuel energy as well, right? It's all energy, not just the renewables. Sure. But gas turbines, whatever other kinds of energy that they've got that aren't renewable, that you couldn't really possibly describe them as green or new either. So yeah, I think I have to just come down on the side of don't like the new name, but I guess I'll get used to it. Well, or maybe I won't. Maybe they'll change it again in 3 months.
I think it's like this is like if you tried to rename Nike or into something, or like Google where they have 40 different companies that all have different names. No matter what it is, it's going to be GE. Sorry.
It'll always be GE.
Just call yourself GE. Who do you work for? GE.
GE.
Okay. That's what it's going to be. Yeah.
Same with
that's
Facebook.
what it has to
does
be.
anybody call it Meta? I mean, I just call it Facebook and Facebook group of companies. That's what when I'm complaining about it.
Is that what you really call it, Rosemary, or what do you really call it?
There might be some extra adjectives, but
The
in
Facebook
general,
companies.
definitely Facebook or directly just attribute it to Zuckerberg. Anything evil that they did.
That's what I'm saying.
Yeah.
So I thought that GE had an opportunity. GE Vernova. I had to keep looking at that. GE Vernova. You had an opportunity to make something really cool. This is the time. This is the one shot in the next 100 years where you could do something really cool and get away with it. Because
what would you have called
what's
it,
GE
Alan?
going to do to you? I don't know. I mean, I was thinking like GE Kick-Ass or GE, we're the best or something, GE Supers. I don't know. It just seems like you got an opportunity. Like it seems like maybe you should have asked around instead of asking a marketing group, because it feels like a marketing group came up with it and started, what they do. They start joining odd words together to make up these names. And I think there's just a better way. In my book, I think you want to make it really stand out. And it just seems like Vernova just doesn't really say. Edison, maybe. There seems like there's something in the history that they could have pulled out and called it something cool, because they are the best naming company for wind turbines, and they do such a great job with that part of it. I thought there would be something really interesting here, but
maybe
nothing.
It doesn't matter what a bunch of engineers think. Maybe that's the point. They're trying to make it appeal to
but we have to
regular people. Not
we don't work in marketing.
There's a reason we don't work in marketing. Is that what you're saying?
Yeah.
Well, we have to wear all the swag when the company picnic comes out and they hand you all the. Plus, you have to wear the name tag thing. It's on your name tag all the time. It's going to be on your T-shirts. It's going to be on every day. You're going to see that 1,000 times a day. It just seems like they just lost and went by an opportunity, but it may work out great. I wish them the best. Obviously, I used to be a GE employee, and Rosemary did too. I hope GE goes forever. I think there's just a lot of history there. I'd hate to lose that.
GE forever. GE
forever. Forever power. It should have had power in it. It should have had power in it. Even if Rosemary gets upset because they're burning oil or natural gas, it doesn't matter.
Call it what it
GE
is.
power.
And I don't
GE
have a
electricity.
problem with gas turbines as a supporting technology for the energy transition. So, yeah, no.
GE dinosaur burners, something like that. Yeah, I mean, they had a chance. They just didn't take it. And, darn it. That's okay. You know, in terms of investment, which one of the three? Let me ask you. Since we already put up our SEC alert for the day, do not trust the words, investment words of any engineer. GE Power, GE Vernova, GE Aerospace, or GE Healthcare. Which one's it's going to come out on top in 5 years? Predictions.
In terms of growth,
I'm taking.
Yeah.
I go healthcare. I'm going to get in early so I can vote for healthcare.
I'm going 50% Vernova, 40% or 30% healthcare, 20% aerospace.
I just choose all of them.
Oh, you think so? I think healthcare is going to be. I think healthcare is going to get limited by the government somehow. If there's the federal government had their way, they would crush the healthcare industry.
People are getting old. All the rich people are getting old, and they have a lot of money to spend to make it a little bit more pleasant for them. So I wouldn't bet against
Once you get
healthcare.
past this wave, though, it's over, right? And then, at least in the United States, the baby boomer wave is starting to crest a little bit. I think it may be.
Yeah. There's a few decades left in it.
Speak for yourself, Rosemary. I think aerospace, weirdly enough, because they can go a lot of different directions. I think they can go a lot of different directions.
I don't know enough about the market.
Well, they're talking about making some electric airplanes, and I think they're ready and they're poised to go do that if they're drawn to it. And I know they've been working in hydrogen for a little while. I think they can go a lot of different directions. There's a lot of money to be made in aviation. There always has been. If the economies are doing okay, you can make a great deal of money in aviation. And you could in power for the longest time, but it's just going to be hard. Maybe, as we're learning at the moment, it seems very likely that Germany's going to have a hard time getting natural gas. Like maybe next week, they won't have it. Maybe GE Vernova may fill that void with a bunch of wind turbines and nuclear power plants or whatever else they're going to do. I don't know. It's going to be interesting. All right, everybody. Thanks for listening. Be sure to subscribe in the show notes to the Uptime Tech News, our weekly newsletter, and also join Rosemary's very popular YouTube channel, Engineering with Rosemary. And we'll see you here next week on the Uptime Wind Energy Podcast.